Thank you, Mr. Chairman, and I thank the Brian and the local organizing committee for giving me the opportunity to stand here and propose a very controversial thought of giving you lessons. I think I'm not really going to be giving you lessons, but this thing has gone too far already. Something is not quite right. Okay, thank you. I think the key point here is that I'm going to give you a little bit of an insight into the inner workings of poultry breeding, and hopefully you will gain one or two things from there. Our industries are not really too different in that, a breeding program is a breeding program. The core objective is to be able to supply stock in a sustainable way to those who is going to need it. The key difference between our industries is the fact that there's a difference in the reproductive efficiency. Our generation interval is different. The size of the bird, of the unit animal is very different, so we can house a lot more in one location, but in cattle you need more space to be able to do that. And of the involvement of the primary producer, but in other words, the commercial farmer, in the process of breed improvement is different. And these are the key things that makes our industries slightly different. This is my take on the cattle breeding program. So forgive me if it's not very accurate. But the key point I want to make here is that the commercial herd, be it the airlight herd or the lower end herd, is a recording unit and is also a source of replacements for these individuals. And they contribute one way or the other to the cost of genetic improvement, in that they contribute something to the cost of data recording and so indirectly to the cost of genetic improvement. But the key factor here is that selection decisions are made at these different units. So gene flow is in all directions, if I may put it that way. In other words, if a very good bull is found in any one of these herds, it can go back to the progeny testing herd. But in poultry breeding, however, all of the genetic improvement and decisions about which animals to keep and which ones to cull are made here. And so gene flow is in one direction, from the apex down to the commercial sector. However, the feedback from these other parts of the industry is very quick and is very, very important. And so you have to be able to respond very quickly to be able to change your breeding objective if you are getting a very strong signal from here that a different product is required. And because of that, I would like to define profitability or success in two main terms. It has to be sustainable. It has to be efficient use of resources. So that's profitability at the breeding program. So in terms of the company that's responsible for investing to produce this superior stock, he has to have a profit, and his profitability depends on these other factors. However, you also have to take into consideration the profitability of your client or your customers. So in poultry breeding, that's very key, that you have these two levels, that you, the breeding program, as well as your clients, because if your client is not profitable, he's going to let you know that immediately. And the moment he stops buying from you, that means you lose your market share, and that means your investment, the probability of you being able to recoup your investment is reduced considerably. So we take profitability of the client very seriously. And that depends on robust performance of the birds that you sell to the person. Those birds have to be disease and defects free, and you have to be able to use them in a sustainable production system. So I would say profitability is, or client satisfaction and fidelity results in your volume of sale. And that's why these two factors are very important in what we do. So it's been argued that rather than looking at the structure of the poultry breeding structure as a pyramid going from the top to down, it's actually two pyramids, one inverted on the other. And this breeding program, which we used to see as the apex at the top, is actually another pyramid which is supporting the entire industry. Because you have to think about not just production today, but production far into the future if we are going to be able to continue to supply poultry meat for human consumption in the increasing demand that is going in the future. So, what's sustainable genetic improvement and what's robustness? What I mean by this is that you need two things. The first one is that you have to have a very broad genetic resource base. Contrary to what perhaps people believe or think, you have to have a broad base if you are going to be able to continue to make year in and year out genetic improvement in even the basic traits. And in our breeding program, for example, we have way over 30 different lines, varying from all sorts of colored breds, naked neck chickens, frizzle feather, all sorts of breeds and populations we keep. Even though we are not producing anything from there, we have to maintain this population. We have populations that we've stopped selecting in 1972, and we just keep, randomly mating them. Another population that we stopped selecting in 1996, and we just keep keeping them on. We have a very big variation in weights, FCR, and breast meat yield in this population that we have. So you have to have this broad genetic pool in order to be able to make sustainable genetic improvement. The second thing that is important is you have to have a broad breeding objective so that you can make balanced genetic improvement. Because if your genetic improvement is not balanced, then you cannot have a bird that is elastic to the micro variations that is going to encounter in the production environment. So breeder traits, live broiler traits, processing traits, and of course, the all-important support traits, which allow the bird to continue to be able to carry the weight it's going to have, are all the key points that must be improved in a balanced way to produce a product that is useful. And this is very important because poultry production or the poultry trade is a global trade. And this is also true for semen trade, as most of you are aware. So you have to contend with production in a very wide array of environments, macro environments, micro environments, something as small as variation in the ingredients used to make the feed can bring about very different performance in the birds. So macro environment, micro environments, but of course also we have a lot of socio-cultural environments where people use this bird. So input and resource use also varies. People who are happy to keep 100 chickens, and as far as they can make a profit from that, their livelihood is ensured. To people who have massive resources for rearing thousands and thousands of breeds. From systems, environments that are fully controlled, to environments that are with little or no control over the production environment. So you have to have a bird or a product that is able to perform across these different environments. So in a performance in the optimum environment, you are challenging a different set of traits. Here the birds can perform to their genetic optimum. So heart and lung function, leg strength, livability, and growth are very key traits that have to be stressed. Otherwise, in a very good production environment, the birds will face these challenges. The same way, if your birds are performing or being used in the production in a suboptimal environment, they have to be resilient. They have to be able to digest whatever feed they are given, because the feed, you don't have control over what feed is supplied to this bird. So they have to be able to withstand it. And that's where a different set of traits are key in having that product that is going to be able to perform in this other environment. So if you are selling to this kind of environment, you must therefore be able to develop a product that is robust, that is elastic to micro changes in the environment. And this brings us to the point of the only way to achieve this is that you have to have data, data from all to create the information required to be able to make decisive decisions about breeding, sales, and management, as well as so forth. And data collection, not for the sake of it, you have to have an objective. What you are recording has to be relevant. You have to consider the cost, because if it's not cost effective, then you probably will not be able to record it. And then it has to be analyzed to bring about the information. In the process of trait improvement, I like to describe it as a process, and this is what we do every day in our own little genetic evaluation unit. You record the data, you store it, and that's where the database management is. Thanks to ALCA, we talk about this, but most discussions in terms of the academic discussions or research is always around these two areas. And ICA has recognized the fact that we have to also balance this point and this point. What tools do we have to be able to make accurate recording of the information we want to record? So, what's the benefit of all of this data that we're talking about? I'm just going to use one example, one trait of economic importance in poultry to make this example. And there's no trait more important, perhaps, than feed conversion efficiency, feed efficiency. measured in feed conversion ratio. So we invest a lot of resources, a lot of money to be able to put in place group FCRO testing facilities, a huge investment in feeding stations. This is what we call feeding stations. What this feeding station does is that it allows you to test your birds individually for their feed efficiency, even though they are in communities, in groups, in the pens, and they are able to, to live and perform just like in the commercial environment. And you are able to then examine all aspects of feed, not just the feed intake, but total feed behavior. If I do a close-up, this is what the feed station looks like. Using transporter technology, individual birds are tagged so that once they go in there, it's recognized, the computer picks up the ID, and the weight of the feed is known. After the feed, the bird has fed and gone away, the weight is calculated, and you know exactly how much the bird has eaten on every visit. So with this kind of system, you have an idea of how many times a day a bird goes to eat over time as it's aging. You know how much it eats every time it visits the station, and you also know, on average, how much the bird eats per day, and then cumulatively over the entire test period. So this kind of behavior, this kind of knowledge, therefore allows us to achieve this genetic progress in feed conversion efficiency, reducing it from 1.9 around in 2006 to what we expect to be around 1.65, 1.7, 1.6, depending on where, where this is in January in 2015. So when you get this much progress, what's the implication of that? Now, let's use one example of Europe. Say, for example, that we project that in 2015, Europe will be requiring about 10 million tons of poultry meat in the EU. Based on the long-term projection of 2.3% FCR, what does this mean? It means that you are going to require about 130 million broilers per week, okay, to produce that much meat for what's required. And if that is the case, at an FCR ratio of 1.8, you are going to need about 26 billion kilograms of feed. And that will cost you, assuming, just rough estimates, this may not be perfect, 33 cents per kilogram of feed. You are going to you require about 8.6 billion euro to produce those birds. That's what it's going to cost just to feed them. Now, if we are able to improve FCR by just 2 points, and the feed conversion ratio is 1.78, then you are going to make a saving of about 95 million euro per year. That is profit to whoever is producing this many broilers to feed Europe. Now, it's not just about money, as one of my favorite pop singers says. Let's make the world go round. What does this mean in terms of sustainability and production? You see that if we pretend and assume that the whole of this feed is just wheat, for example, we are talking about, also making assumptions about the yield. It may not be perfect, but we're assuming a yield of about 8 tons per hectare. This saves you about 36,000 hectares of wheat in 1 year. And that is wheat that can be used in other places. So, improved FCR means less feed required for Europe. If we pretend as if the feed is all wheat, that's up to 36,000 hectares per year. This means increased profit of about 96 million in the pockets of the broiler commercial producers. And that's what we're talking about. So from data recording to generating the information and producing a product that is efficient in performance and putting money in your pockets. I think at this point, I hope that I've delivered the message, really the thing I was asked to come and say here on the importance of profitability in making progress. However, if I still have 5 or 2 minutes, I would like to give you a little bit of an insight into the inner workings of a real broiler breeding program and how it works. And I'm sure many people would like to know a little bit about it. Aviagen is a broiler breeding company. We have our office, our database, our centralized systems, genetic evaluation, everything happening here in a little town called Newbridge in Scotland, near Edinburgh. And from that point, we have distribution networks around the world. We have a second breeding program in the USA. Now, if you make our breeding unit is 1 male and 10 females. From that, you can presumably get about 68,000 tons of meat, broiler meat on the ground. So selection accuracy to select this one male and the 10 females to go with it has this impact. If you are wrong here, you're catastrophically wrong down here, and you will know about it within 4 years, very quickly. And so it takes about 4 years, just to go from here to here, right? So just a quick go through. Because of the impact that we have, one male and 10 females have on production, you see quickly why biosecurity is more important, actually, than genetic evaluation or breed improvement in our breeding program. Because we have to sign a commitment, what you sell to the commercial farmer, it has to be disease-free, it has to be free of all of these, for example. And if they have a disease outbreak because of you, they come back to you straight away. So accurate selection is important. And for this, you have to have unique IDs, recording of relevant traits, accurate breeding values. And this process is really a dynamic process. So over the years, we move with times. We used to do mass selection in the 60s. And as the tools and the technologies change, we have had to change. Blob came in, multi-environment changing. We do FCR testing. And now, up to the point where we are trying to implement using an X-ray equipment to measure leg defects. So you can see microeconomic leg defects. Okay. So, it's just running through what we have, and I think I can stop whenever we finish. This is our breeding unit. Here you are able to record fertility information. So because every bird is trap nested, every egg is recorded as it's picked up, and the ID you write on the egg the day you pick it up translates into the ID of the wing of the chick from the day it's hatched. And that stays with the chick until the day it's culled or processed in the plant. Reproductive traits, because we know that they are correlated traits, we record all the correlated traits as well in order to try to improve these two traits, fertility and hatchability. In the growing sector, yield recorded on live birds, that's scoring, objective scoring, ultrasound, and now the X-ray as well. And then we actually have birds that are sent to a processing plant where every bird is individually processed and cut up so that we can know the components of fat, legs, wings, and breast meat yield, and so on and so forth. The support systems, this is a lexiscope we started using long time ago, using X-ray technology so that you can see on a live bird whether it's got a problem on its leg or not. And any bird that has any slight defect at all is called immediately and doesn't contribute to the next generation. So this is the ultrasound X-ray equipment. Now you can see this bird. This is a live bird, and straight away you can know whether it's going to develop a problem, and then it's called. So very intensive selection for all of these traits. Metabolic strength, we use something called oximeter to measure oxygen saturation. And we can claim that we have been able to reduce the incidence of ascites over time just because of selection on these traits. Genomics is a new era, but like we say, it's going to allow us to do all of these things, but I couldn't resist borrowing a slide from my friends. We are going to continue to record the phenotypic data, and the concept is that with that, we combine it with this one here, and we are going to be able to achieve a best accuracy. So as this is what we call our learning curve, so you hear a lot of terminologies, starting from genome-wide association, genotyping, SNP chips, genotype. For me, what all of this means is more data. So I couldn't resist borrowing this from my friend, not only because it's true, Mike said it, but also Mike is my neighbor, so I'm sure he wouldn't mind. We still have to keep recording the data. And this is the infrastructure, for example, that we had to put in place to facilitate this integration. So in conclusion, Mr. Chairman, data recording is an essential activity in the breeding program. Analysis provides information, and that information is what is responsible for you to be able to make timely decisions. So profitability depends on accuracy of available information and sustainable genetic improvement. Thank you very much.
Okay.